Okay, now let us consider one example where we actually want to find voltage across one particular element shown in the circuit, that is 2 ohm resistor. But here I want to demonstrate superposition theorem, that is application of superposition theorem. So effective voltage across this 2 ohm resistor we will be finding out considering first of all this first source, that is 10 volt, then one more current source, that is 2 ampere, and the third one again voltage source, that is 20 volt. So one by one we will find out effective voltage across 2 ohm resistors due to individual sources. So let us find voltage across 2 ohm due to individual sources, that is algebraic sum of all these voltages will be the ultimately the total voltage across 2 ohm. Now first of all we will consider this 10 volt, and when we consider voltage source and remaining other sources, that is current source, if it is there we have to open that, and voltage source if it is there then you have to short that. So we are going to open this particular current source, so therefore this 3 ohm will become non-operative, and this voltage source we have to short. So resultant circuit will look like this: 10 volt is as it is, this 10 ohm is as it is, this 2 ohm is as it is, this 20 ohm is as it is, this portion is acting as open circuit, and this 5 ohm and this 20 volt is shorted. So this 5 ohm resistor is connected like this. So resultant circuit will be 10 volt, 10 ohm, 2 ohm, 20 ohm and 5 ohm. We want to find out voltage drop across this 2 ohm. So what we are doing is in the first case, directly we will solve this. Suppose here we will consider this V voltage, that is V minus 10 divided by this 10 ohm plus V minus 0 divided by this 20 here, and V divided by 2 plus 5, that is 7. Considering this figure A, this is node equation. We have applied here node analysis. So V minus 10 volt divided by 10, V minus 0 divided by 20, and V minus 0 again divided by 2 plus 5. This total will be 7. So like this, algebraic sum of all currents at node A, or where the potential is assumed to be V at node A, is as if is equal to 0. All the currents we have assumed that is leaving from this node, and therefore we have written V minus 10, V minus 0, V minus 0. So 0 I have not written explicitly, but you have to consider this V minus another potential is nothing but 0 potential. Okay, so total will be this, whatever V is coming, V is equal to 3.41. This just separated terms, V is taken common and then simplified little bit, and total voltage is coming. You can tally this one. So in this short videos I am not supposed to waste my time in actually mathematical substitution part and solving simple equations. So that's why I am directly treating this particular resultant expression and then ultimate value of V. Now in this case, so voltage across 2 ohm resistor will be due to 10 volt source V2. I am writing is equal to V into 2 divided by 7. That is resistor total, this V potential. So here it is, we are applying voltage division rule, not in this circuit, sorry, this circuit. So here it is V potential, voltage division rule we will apply. So voltage drop across 2 ohm will be the same resistor voltage division rule multiplied by the voltage divided by total resistor, that is 2 plus 5. So that's why it is coming V divided by 7 and multiplied by 2 ohm. So V is 3.41 something. So divided by 7 into 2, that is giving us 0.97 volt. Now second step is to find voltage across 2 ohm due to 20 volt source. Now the another source, rest of the sources, that is when we are considering this 20 volt effective, then this will become non-operative. Therefore here you have to short. This is open. So second circuit will look like this figure: 10 ohm as it is, this portion as it is, this is 22, and 20 volt battery and this 5 ohm series resistor. Now while solving this, again we will write node equations. So this will be, yes, just here you can see V, same potential, V minus 20 divided by 5 plus 2, that is 7. So V minus 20 divided by 7, first term. Second term will be V minus 0 divided by 20, and third term will be V minus 0 divided by 10. So again node analysis. So these three leaving currents at node A with potential V we have written. Simplified little bit, V is taken common, and second voltage is coming 9.76. Again voltage division rule we will apply. Voltage across 2 ohm will be equal to, voltage across this 2 ohm will be equal to V minus 20 divide by 2. So therefore here we are writing divide by 7, sorry. So V minus 20 divided by 7 into this particular 2 ohm resistor. So V2 will be coming out to be minus 2.92. Now the last step, that is effective voltage due to this 2 ampere current source. So for that we have to consider that 2 ampere and 3 ohm branch as it is. 20 volt battery from this branch is shorted. Here 10 volt battery is shorted. So resultant will be 10 ohm, 20 ohm, this 2 ohm, 3 ohm current source and 5. Now if suppose only 2 ampere current source we have kept, so current through 2 ohm we can calculate. This 2 ampere is coming here and we will apply current division rule. So 2 ampere current into other resistor means when your current is coming here, some current will go in this direction, some current will go in this direction. So as per current division rule, other resistor should appear in numerator and divide by current is going in this direction. So effective resistor, that will be 10 parallel 20 and in series with 2. So total it is becoming 10 parallel 20 is 10 into 20, 200 divided by 30. So approximately 6 point something, and in that 2 ohm. So total it is coming 8.67. Just see how this 8.67 is coming. This is 10 parallel 20. Resultant will be 200 divided by 30. That is 20 upon 3. So 6 point is 20 upon 3. Remaining is 2. So 6.6 something, 6.6 plus this 2. So therefore 8.6 or 8.67. Now total will be 10 divided by this 13.67. So current is flowing through this 2 ohm is 0.73, and therefore voltage drop across 2 ohm will be 0.73 into 2, that is 1.46. So total voltage, that is the algebraic sum. So V is equal to 0.97 minus 2.92 minus 1.46 is equal to minus 3.41 volt. So wherever this voltage is coming minus because of the current direction, accordingly I have considered the sign. So whatever value is coming, so that is taken. So here one value, this is 3.41, one minus 2.92, and one is 0.97, and one is 1.46. So all together this is giving us effective voltage drop. So this is about superposition theorem.